All right, welcome to week 11. This is lecture here out of the book here. This is going to be more SQL querying. Just a lot of this should be review for you guys because we've kind of gone over this with the SQL lessons as we're going side by side on this. But review is always a good thing. You can honestly probably never have too much review. So let's go ahead. Let's pop over here and let's look at the slide deck. So let's remember some query basics here we have. Now, keep in mind, very important, the order. And this order's off because I don't like it, but I'll explain why. But we have select, and that defines the fields you want to run, or the columns. From, that's the table you're querying. You got to have at least those two for any query. Where, that's your filter, restricts what you want. Group by, when you're aggregating, that's how you group your results into subsets that enables the query to perform aggregation on each subset. So if I've got teams and scores, and I say, group by teams, give me the average score. It'll take each team and average their score out each time for you. Order by tells what order you want it in. I would put order by at the bottom of this table only because you order by always at the end. Inner join, that's for how do you combine two tables together in comment field. We've gone over some joins. And then union, I don't think we've gone over this one before. Union combines two separate result sets together that contain the same field. They have to exactly match. You have to have two different tables that match. Okay. So aggregates, I agree, one of the most powerful things you can do in SQL. People use data. They want to do statistical analysis on it. So use aggregates, and you can turn massive amounts of data. You can look at it quickly, get a good, statistical feel for all, when you have such like millions of records like I do at work. I can't look at them all. I can't read each one. So it's good just to get a quick estimate. So let's look at a couple examples. Here we have count. So we say select count as record count from student. Now this as record count is aliasing. We've gone over this before. And we know count star is going to count everything. So what it's going to do is it's going to return how many records are in that table. So we don't need a group by because the only thing we have in the select statement is the aggregate. Okay. Now we have select first enrolled and then count as student count. And we're going to group by first enrolled. So you have to group by anything that's not an aggregate has to be in the group by statement. So we group by first enrolled, and that's be the date. So what it's going to do is you're going to have this right here would return, if this is all our data, it will return two records. One record would be 2010 and one would be 2011. And 2010 would have 3 next to it, and 2011 would have 2 next to it. Okay? And like I said, we've seen this before. We can also have averages, minimums. So we're doing the same thing, grouping by degree. And we have to group by because the degree is not part of the aggregate function. Now, if I had set this up where I put average and sum of the GPA, I would not have to put anything else in the group by because these are both aggregates. So you'll just have two columns after the degree. Okay, so this one will return the average GPA for the degree program. This one's going to return the minimum GPA. We've also got other functions like sum, max. There's so many really to go over. But that's the idea behind that. See, now we have two non-aggregates in the select column. So we have to group by city and first enrolled. Okay, again, if I had put a second GPA thing here, if I'd done sum of the GPA, I wouldn't have to put anything else in the group by because that's another aggregate. But because these are both non-aggregates, they have to be in the group by. And you'll get reminded, if you run it without there, you'll get an error that's saying, non-aggregate has to be grouped by. And notice we also added a where statement here. So we're looking at first enrolled, city. So we're only going to return Newark. So you're going to get two records again, 2010 and 2011, because get rid of the Bridgewater, and you're just 2010 is going to have 1 and 20 or 8 average AP. 2010 is going to have 2.8 and whatever 3.7 and 4.0 are aggregated. And they are going to be ordered by first enrolled descending. okay, which is, remember, descending is not default. Order by first enrolled would have been ascending, descending. So descending will start at 2011 and go down to 2010. Joins. We've gone over this a couple times. We actually went over all 4 joins. This is just the inner join. And again, the inner join is default. So you actually don't have to put the word inner in. It requires only the common values go across when you're joining. So remember when we join, and again, this word inner does not need to be there because by default it's there. We're going to select first, last name from student, join enrollment on student ID is enrollment ID, and where course is Comp 102 and year. So what we're doing basically is we're getting just the names of the students who are taking this class in 2010. So that's what that did. And you always remember you have to join on a function. So the student ID and student ID both join. And you notice this student enrollment, that's the tables names. Student.student ID, enrollment.student ID. This is why I always tell you to alias your tables when you're doing a join. So you don't have to write the whole thing out each time. And in here, that's what we've done. We started to alias the tables. We put an S there. So looking at this one, we've got student name. Now notice even up here, it's going to tell you where they're from here. So you got the student first name and last name all come from the S student table. Inner join enrollment and the year and grade both have an E in front of them up here. That means they come from this table over here. And we just inner join on student ID equals student ID. And then the rest of this is all just the where statement, where the last name's King, first name's Stephen, and the year is in. If you remember in, it looks at anything in there. So if I had 3 or 4, I could keep going, just you separate them by a comma, and then we're going to group by. We have to group by because we have an aggregate. Notice we have 3 things we have to group by. Name, last name, and year, because none of them are aggregates, only the average grade is the aggregate. Okay? And again, we're going through this fast just because you guys have done this already, and this is just a refresher. Really. Return the student's first name and last name along with every field in the enrollment table. So there you just sit there and say first name and last name and everything in the enrollment table right there. Okay? From students inner join. And that'll bring you, everything along here. So now finally you have unions. Unions are combining these 2 results. So I have a query here where I'm saying I want the first and last name from the students where the city is Bridgewater and the degree is economics. And I also want to run a query with first and last name where the student, where the city is Newark and the degree is biology. So I would get 2 different result tables out of that. Because these tables are exactly the same, they both contain a first and last name only, I can union this and it'll come out as one big table. Now, only problem is you're not going to know who's what. You're just going to get a bunch of student names. You're not going to know who is Bridgewater, who is Newark. But if that you don't care about that, then that's what you're going to get. Okay. Indexes. Indexes are very important in databases, especially, from the DBA standpoint, performance. Your database is slowing down. It's hard. Your reads are very slow. Indexes work just like a book index does. What you do is you're going to index on columns that you think people are going to search on. So you don't want to index, you wouldn't want to index like on your G number, nothing like that, because you want to index on things like dates or like the subject or things of that nature. So using the index, it's like being in a book. You can go to the back of the book and I can look up, let's just say I've got a table on these product types here, BA1, BA. So I would look up in the index BA2 and it would tell me every record that is a BA2. So I don't have to go searching. If I had 1 million records here, I don't have to search all 1 million records to find all the BA2s because the index would tell me the 30 records that are a BA. Indexes are, an interesting thing. You could get into plenty of arguments with people over indexing because too much indexing can actually slow down a database. Not enough indexing can, speed it up. But the one thing to think about, indexing slows down your writability speed, because if I am writing to a table and I have a bunch of indexes in there, every record I add, I have to go and touch the index and fix the index. Reading, though, it is remarkably faster because I don't have to read every row. I can just check the index out. It's not, I don't have to go to a book and read every page to find every reference to whatever I'm looking for. I go to the index and tell me what pages it's in. But again, so you're going to sacrifice writing speed for reading. So you're going to find that your reporting databases are much more heavily indexed than your writing databases. So without an index, the table without an index is similar to a random pile of playing cards. If I give you another card to add to the pile, you just simply add it to the top wherever you want. Adding a new card takes no time. It's quick. If I want to ask you to find the 10 of spades, you're going to have to look through the whole pile to find it. So that's slow. With an index, if I told you to keep the cards in separate piles based on a number value, you would have to rearrange the location of the cards that you would have. If I give you another card, you would have to find the correct pile where that card belongs and insert it. So it's slower. It takes more time. And indexes, you can see where indexes kind of break up quickly as, these piles. You got let's say you got piles for cards set up and you have 4, 5, 7. Those are your piles. And also now I give you a 6. Well, you're going to have to move 7 over a 6 to fit there. So it slows down your writes, but it's much faster when it comes to reading because now you don't have to look at every single card just to find the 10 of spades because you should have a pile of tens. All right. So again, tables with appropriate index, inserts are slower, queries are faster. Without an index, inserts are faster, queries are slower. Many times you add indexes when query performance becomes a problem, and that's very important. And sometimes you'll only add indexes. I do it a lot where I literally will add an index just for a couple queries, and I'll kill the index so it doesn't later cause slowdown problems in the database. Sometimes you just need it long enough to run the query you want. Finally, let's go ahead and look at views. We did views last week. A view is just a way to store a search, a query. So again, the code is very simple. Create view, the name of the view as, and then put your query down there. And now every time I run, now if I just run select contract BS1, it's going to run this query for me. So again, views are great. They don't take up much room because they don't store data. All they do is they store a query. Good. All right. So again, this was kind of a quick review because you guys have mostly seen all of this. And again, look forward to seeing you in the next class. Have a good one.